First, I want to say thanks to KubeCon for giving us this opportunity today, but also thank you to all of you for coming out to see our talk. My name is Brad Whitfield. I am a distinguished engineer in our platform engineering excellence space.
And I'm Jake Walden. I'm a technical product owner within our engineering excellence organization at Capital One. And I lead a large team that supports a very large multi-tenant compute platform built on top of Kubernetes. We've been building platforms since 2018. And today we want to talk about the natural evolution of platforms using our platform as an example. Today you'll hear about the environmental pressures you can expect to find in any platform's journey and the adaptations required to survive. When we think about platform evolution, we think of artificial and natural selection. Artificial selection is kind of like that tree that you see here on the left. It's recently been planted, but its trunk is straight, but if there were a strong wind to come through, it might knock it right over without those supports. We compare that to an enterprise platform built out of declaration. It might be built directly to exact specifications, but it hasn't been hardened by the adaptations of its environment. Your workload may even have to adapt to the platform to run there. Take that in conjunction with a natural selection, right? The tree there on the right. This tree has been subjected to natural pressures over a long period of time. It's adapted to its environment. Sure, it's growing a little bit more slowly. It's not as picturesque, but its roots are very deep and resilient. And we compare that to a platform that started in a small corner of your organization, right? This tree or this platform, it was built to solve a specific problem and had a quick and iterative feedback loop and early. So it adapted to its environment and grew much more stronger through organic adoption. So we're a little biased because Dragon, our platform, was built in much the same way. I've already said it, but the name of our internal platform is called Dragon. It's a multi-tenant compute platform that we originally built to support just microservices, but have since expanded to support advanced use cases with a namespace as a service tenancy model. We've even begun managing resources outside the cluster by leveraging controllers. During this talk, we'll talk about the evolutionary principles to frame our journey in stages. So stage one, in the beginning, platform inception, there are external pressures and there are adaptations. You can think of external pressures as environmental factors, potential threats to the survival of your platform. Well, adaptations are the changes that you will make to adjust to your current environment and survive. The two main external pressures that we experienced in stage one in our platform inception were speed and distractions. Speed meaning you have to get an MVP out as fast as possible before the goodwill or the money runs out. And distractions meaning, we're all engineers, right? We're very curious. We want to install every tool that's out there, right? You guys all saw the vendor booths down there, right? Did anybody else feel like, hey, I want to install every tool here and take it home? I know I did, right? Don't fall into that pitfall in stage one. You're going to end up with a very high feature set that you just can't maintain. So that's the first iteration, or that's the first adaptation, is limiting your feature set. You want to push any unnecessary automation to the backlog. It's okay that it's not all automated. You don't really know what to automate at this point. You don't know how your tenants are really going to use your platform in stage one. So that's also why I recommend that you don't build a ton of documentation, because you might build a lot of documentation that nobody really wants to read. So when we started it with Dragon, we actually built it on ECS EC2, which was honestly a great starting point. Remember, it was about 2018, okay, so give me a little bit of a grace here, but it allowed us to move pretty quickly. And we were able to use AWS services to propel us forward. We got an MVP out. We were able to stay with a singular microservice model, and we kept things simple, and we showed clear value immediately. But we quickly started to notice weaknesses as the platform grew in size. Lack of automation. We made decisions not to create a bunch of automation right up front, but we started to pay for that as we started to grow. The documentation that we decided not to create meant that the tenant teams then had to interact with us for every problem they had. So that took a lot of our time. We had to also train the organization on SRE principles, and concepts like the 12-factor app weren't well understood at the time. So that was a big hill to climb as well. We also started to see technical weaknesses. So we would provision separate ALBs for each function and domain, and those became very difficult to maintain and expensive. We also started to see API rate limiting issues. We ran into limits on ALBs for a 100 rule limit. I think there was a 100 rule limit on ALBs back in the day, and so we started to run into that. We knew that there were opportunities to optimize in our current stance, but we knew we were going to Kubernetes, so we weren't going to spend the time. That brings us to stage 2. Your tech debt payments are now due, right? In stage 2, all the changes that you made in stage 1, all the sacrifices, are now requirements for stabilization in stage 2. Your expectations are higher now that you're in production. Your team might start to feel a little burnt out from everything being new. So it's really key in stage 2 that you focus on operations. Instill a lot of those SRE requirements, so SLI, SLO, SLAs, and make sure you're exposing those to your tenants. Transparency is a good thing in stage 2. So it's not really so much that you have an incidents, but it's also how you handle them that's important, and we'll talk about this in the next slide. But as you grow in your tenants, that documentation and the refinement and process can really save your team from ending up in a lot of long, drawn-out conversations and confusion just wholesale across the company. One interesting phenomenon that we noticed in stage 2 was that there's this inverse relationship between platform trust and the support and toil that your team has to overcome to manage a good platform. I compare this to, has anybody ever had multiple incidents in a week? Anybody? Come on, raise your hands. I know you're out there. Come on. After those 2 incidents, for the next couple weeks, your tenants probably think everything is a platform problem, right? So now your job as a support team is to prove that it's not a platform problem, which is really exhausting if you've ever been in that situation. So your support and your toil goes vertical, right? So it's really important that you build the platform trust in this stage to prevent that from happening in later seasons of the platform. So now I'm going to pass it to Brad, and Brad's going to talk to us about our move to Kubernetes.
Thank you. So just a quick call out for everyone too. We did upload these slides in PDF form on the Schedule site, or schedule.com or whatever it is. So you can find all of these there. By all means, take your photos if you like, but if that's easier for you. All right. Excuse me. So our move from ECS to Kubernetes was really our first, what we consider platform level migration. So this was when we really kind of had that light bulb moment and saw the power of the platform, what this could offer for people. So ultimately what we did wasn't anything glamorous, but we created a way where teams deployed their service to both Kubernetes and ECS. They could validate it in Kubernetes. They would undeploy it from ECS. And what we would do is we'd update the target group to point at this Nginx forwarding service. And all this did was we created another host name to point to Kubernetes that just had the -forward suffix in the beginning of it. So that way, this Nginx pod had a clean DNS name to point to, because you can't point a DNS name at 2 different load balancers. And remember, we had to do this multiple load balancer thing because we just had too many services basically we couldn't fit them all on one ALB. So as you would move everything behind a feature to Kubernetes, we could then go trash the -forward suffix hostname and flip you completely over to Kubernetes, move the original host name over to Kubernetes. And with this, we saw immediate benefits, right? Because now we're on Kubernetes, so we get DNS-based service discovery, so we didn't have to bolt something onto the platform or use serve records and have them bake that into their code. We also got, we got the Nginx ingress controller at this stage because this was pre-gateway API. So now we got past that rule limitation that we had. So it was 1 NLB. Actually, it was an ELB at the time. And then we got Kubernetes secrets management for more seamless secrets management experience. All right, and this is what it looked like in the beginning, right? So we took deployments in and we generated them with Go templates. So customers at this point, they would give us this pretty standard 80-20 microservice rule. So like I need my CPU, my memory, my number of replicas, my host and path. And then we would scaffold that out to be all the underlying Kubernetes resources for them. And at this time, we had heard lots of people, like even now, there are lots of people who start this way, right? Because at this point, you don't have the Kubernetes expertise to go write operators. And when we did this, the operator SDK was either like brand new or it didn't exist yet. But as simple as this sounds, this was a huge accelerator for us because we had pretty robust tests around the deployment API that did all this scaffolding. So it actually allowed us to iterate much more quickly, and the Kubernetes APIs, being this like very consistent experience, were much easier to work with. So we got a huge amount of leverage just by moving to this, but we were still very early in on learning Kubernetes and our Kubernetes journey. We didn't even have PDBs at the time because they weren't on our radar. But like I mentioned on the last slide, this kind of opened the door to Kubernetes for us. So the DNS-based service discovery, the better secrets management. And then as we evolved, we started writing things, or we started using controllers and admission hooks so we could automate like the RBAC and network policy creation. And then shortly after the operator SDK started to stabilize, or kube builder started to stabilize, we built features like we built a Redis cache, was the first one we did with the operator, so people could just add to this deployment payload, like, hey, I want a Redis cache, and then we'd wire all that up for them. But you can see that once we're on Kubernetes, we really started to evolve and build on it more and more over time to provide more for teams. All right, so then comes stage 3, multi-tenancy, right? So prior to this, we were still mostly building for one small corner. And as we built this out more and more, we started to look into what does it look like to do this for more and more people. So you'll find in your company, if you're going this route, you'll find in your company that there are a lot of people doing probably the same thing you are, or very similar. And this is what we call the convergent evolution, right? Because multiple things are evolving in the same trait or similar traits. And partnering with these teams is really where you're going to gain a lot of efficiency. So find these people in your organization. Any sufficiently large organization, you're going to see duplication. And there are multiple strategies when you get to this point, when you're working with them, to augment the work, right? So you've got shared expertise or knowledge transfer or headcount transfers that you can do here. Because sometimes people just like, or other times there are people who just don't have the expertise to run things anymore. So really, these build a lot of goodwill, these partnerships build a lot of goodwill with them. So your external pressures, you're looking at resource efficiency, right? So you start to make better business decisions by consolidating and ultimately what are we here to do other than like help drive the business forward. And then your 20% of features, though, that serve the 80% of use cases, it's likely going to shift too. So these could be small things like header manipulation, or it might be some external, or other enterprise tool that you need to integrate with, right? So if we kind of look at these adaptations, big one to call it right away is your tenant isolation and auditing, right? So you need to be able to speak to your network flows, make sure they're doing what they're supposed to be able to. You need to have proper RBAC in place to make sure tenants aren't stomping on each other, can't do anything malicious, intentionally or unintentionally. You got to make sure pipelines are secure, right? So you don't want it to be that like anyone who's running something on the CI server can deploy on top of anyone else's workload. You need to make sure that that's properly gated. And resource control, noisy neighbor, things like that. Tenant support and self-service. Right? So going back to kind of what Jake was talking about earlier, your support channel, your intake is going to grow as you look into multi-tenancy. So you really need to figure out how to handle this, because if you don't have good support, you don't have users. No one's going to want to use a platform that's not supported. So support really needs to become a first-class citizen, like a first-class feature of your platform. And then how you do this is often overlooked, right? So now's the time when you start to really make your docs more concrete, your automation needs to be better, get user feedback through surveys, empathy interviews, things like that. Also, then you start to look at the shared responsibility model and the incident management, because process matters. It's not the fun or glamorous things, but it's really important to have these lines defined, these boundaries defined, if you're not going to burn out. So the other adaptation here is your features, right? So you're going to start to selectively add new features, but try to stick to what's the core of your platform. You don't want to deviate too much, because then you, again, get to that unmaintainability trap. Yeah, and then, yeah, the other call out here that's not directly on the slide is at this point, with all these relationships you're building, you're starting to network more probably with like your security teams, your audit teams, your IAM teams, like your internal cloud teams. Lean into these. These will pay off big in the long run. All right, so what did multi-tenancy look like for us? This, pretty much. It's a little hard to get it all in the diagram, but ultimately, we had a couple of monolithic clusters across regions and environments. So we had like a non-prod and a prod and an east and a west, that sort of thing. It wasn't pristine, but it was robust. It got the job done. It ran well. So we lean heavily into controllers and admission controllers for multi-tenancy at this point. So using the information the pipeline provided us, we were able to make sure like applications were stepping on each other and deployed to the namespaces they should be deployed to. And then we started to use controllers to build new use cases like network policies. The network policy controller, I probably can't really see down there, but we had a network policy controller that allowed you to start exposing network policies in controlled ways, like services across namespaces that belong to the same CMDB application, because everything here ties to a CMDB application. And then we also started working with like our IAM team to use KIM, at least at the time, to provide secure cross-account role assumption and make sure we were compliant and all that. And then teams started to move to us because they wanted to shut down their own ECS clusters, right? Like they saw the power in bin packing and letting us run their stuff for them. They still own their applications, but they no longer had to maintain clusters. Yeah. So then we get to stage 4, the rewrite. And this is where everyone wants to be like tomorrow. You really got to work to get there, though. Like, you've got to go through this evolution. Because at a certain point, though, you're going to start to see the limitations of what you've built. And this third rewrite is really a turning point for the platform. Because, they say in software engineering that, like, the first time you're just learning the problem. The second time you kind of know the problem a little better. The third time is when you really know what you're doing. And that's when you build, like, the more pristine version. So at this point, your Kubernetes expertise has grown. The manual tasks don't scale. And then the templated YAML at this point has become inflexible and hard to maintain. So this is when you start to look into moving to CRDs to manage your platform, and starting to really lean into that control loop to reduce your RT, your tenant team's RTEs, and those partnerships I mentioned you build along the way. When you're using the control loop, you can start to push enterprise-like initiatives into the platform and then use the control loop to show the desired state and the current state to show to security teams and audit teams, look, this is the state of things, we're in a good shape, or we need to address XYZ thing. And then you're also going to start to unlock new use cases at this point, because now you're using the control loop, you can start to unlock namespace as a service, which we'll talk about in a minute, and cloud resource management. And ultimately, though, when you do this, the ownership lines become redrawn because you've changed the abstraction layer, right? So how do you do that in a way that empowers teams, it emphasizes the happy path, but also doesn't unnecessarily hide things from them if they really need to get in to see what's going on underneath? And there are multiple ways to do this. You could do like Crow, Kubevela, or just raw CRDs. And this was our implementation of that. We did raw CRDs. So this is the initial version of what we call the Dragon operator. And we codified Capital One standards into 3 main CRDs at the time. And the main entry point to this cluster was the CMDB application at the top. And this created the isolation controls. So a lot of that stuff that was ad hoc controllers and Go templates before, now we're handled by this. So teams would come to us when they would come to us, they would give us like minimal information, as minimal as we could get away with, basically, to try and make it easy for them. So they would give us like the team info, who to page in the event of an incident, their resource requirements, which pipelines to expect deployments from. And then we would take that and we'd scaffold out all the like resource quotas, the namespaces, the network policies, the role bindings. All right, and then at the bottom are the 2 CRDs that you would use if you're actually deploying code to our platform. The first one is the service. This is kind of the more common one. This is kind of like what we were looking at with the Go templates before. This is what it turned into, right? So we created a CRD that creates like your deployment, your network connectivity, your service account for identity things. And then we started to expand on this more and more, because once we got comfortable with operators and could really start to reconcile things with the control loop, we started to add features like, we had the Redis cache earlier. We kind of evolved the Redis cache. And then like if you wanted to ensure that you were securing traffic from our internal API gateway, that became a feature toggle. And this was just like out of the gate. There's more that we'll talk about in a minute here. Yeah, and the cron job thing is the CMDB job is pretty much just a cron job with an identity and service account. All right, so earlier we mentioned partnerships. One of the biggest ones is we came together internally as a Kubernetes community, and we standardized on a central method of provisioning clusters. And for us, that was OneKube, because we're capital One. A lot of the internal products have one in the name. And our OneKube partners are actually, a lot of them are over there right now. Yeah, so ultimately, we had built these partnerships with like cyber and audit and risk and security, or cyber and security, sorry, governance like IAM. And centralizing these into one method of provisioning actually streamlined a lot of stuff for us, because not only could we focus more on like maintaining our platform and less on the underpinnings, but also now when the cybersecurity team needed to update some agent that we have to do for compliance, they had one place to go to, whereas before it's like some of us might have been running Containerd, some of us might have been running CRIO, so then they would have to like work with all of us kind of bespoke. So this really accelerated a lot. So underpinning our platform, we have the cloud provider, which we're primarily using EKS at the moment. And then OneKube provides the layer on top, which is the like out of the box, this is how you have a compliant cluster at Capital One. Then our foundational, or we call it the foundational platform in this diagram, is Dragon on top of that. Then we started getting into platforms on top of platforms. And this is where we had a rules platform and an orchestration platform and a couple others that aren't on this diagram that built on top of these things we offered with like the CMDB application. And then ultimately the developer teams, right? They should only care about their little tiny bit of the pyramid and not all the underpinnings underneath. So continuing to evolve and evolve on those partnerships. Our partnerships with OneKube and Cyber, our security teams internally, and plus our proficiency in Kubernetes and like operating and developing on it, put us in a good place to continue to provision more and more with operators. So we got some serious like RTE reduction over time, or ultimately like all this is for reducing RTE for both us and the developers, right? So the cybersecurity teams and the IAM teams at this point, they kind of had an idea of what we were going for. So we were kind of aligned on the goals and the technology, and we worked with them to craft solutions that were compliant and built on top of OneKube. So as we continue to expand the operator, we got better isolation controls and supported more advanced use cases. So like we did secrets management with external secrets, and more scaling options with Kata. And then over time we added node pools per CMDB application. Working with our IAM team, we built an operator that uses our internal tool that validates that you're doing basically everything you should be doing with IAM roles correctly. We built an operator that interfaces with that system so team could continue to get the power of the reconciliation loop, and we could build features in where they wouldn't have to bring the role themselves. Yeah, and then the other big thing is we started to open the door to Argo CD for more advanced use cases, right? So we were kind of using it ourselves to manage a lot of the platform. But once we had this CMDB application, we could take all that and map it into an Argo CD app project. And make sure we have the appropriate isolation controls and all that in place. And then teams could bring their more advanced use cases that use Helm or Customize or Raw Manifest to our platform. And back to you.
Thanks, Brad. All right, we're in stage 5. And actually, this is kind of where we're at today. Exponential growth. So by this stage, you've likely built a very valuable platform, and you're starting to see this network effect where other teams are telling other teams about how much they like your platform, and you almost have like this thundering herd problem, right? So the two external pressures are your cluster count is going to grow rapidly. I know we grew by 6x in the last 12 months, which is really tough. And then also, new platforms become your tenants. And Brad alluded to this a little bit ago, but platforms on top of your platform. So you're kind of like this bottom layer supporting all these other platforms that are building their own operators and bringing them on to provide other experiences for teams. So our adaptations, or the steps that we're taking, is we really need to start treating our clusters like cattle. You guys have heard this forever about servers, but with clusters, it's a bit more challenging to support this and to treat your clusters like cattle. There are a whole other host of problems that come with this. One of them being, now because you're treating your clusters like cattle, like you're swapping them out constantly, you can't address them directly. You have to describe them. And so in order to avoid having all of your tenants have to change something in their repository each time you swap out a cluster, you need to figure out some kind of a proxy in front of that. So we're working on that. It's also very likely that you're going to require a service mesh. So in order for cluster A and cluster B to be hot swappable, you're going to have a lot of tenants that are using service discovery to talk to their services within the cluster. And you really can't support this without a service mesh. You have to be able to move services independently from one cluster to the next without breaking that communication. And the last and probably the most challenging part of stage 5 is that your clusters have to be able to grow independent of your headcount. It's really tough to go to leadership and say, hey, we need 50 more clusters, and with that, I need 10 more people, right? It doesn't scale very well. And so that's why automation and a lot of these advanced tools become so important in stage 5. So what's next for us? We're borrowing some of the same techniques you would use to manage applications and applying them to a fleet. Right? We're breaking things up into different layers. We're trying to centralize our management and network planes and operate many of our clusters in a hub and spoke model. Our hope is this approach will reduce the blast radius at the application layer, open up the ability to scale horizontally at each layer, and also allow us to abstract the control plane to prevent constant configuration changes. Kind of like back to what I was saying about having, in order to have hot swappable clusters, you can't address them, you have to describe them. In closing, this is going to take time, and that's okay. I think we've kind of walked you through the 5 stages. I mean, we really walked through 7 years of evolution. You're not going to get there tomorrow, but it's always better to walk to the right solution rather than run to the wrong one. So make sure you take time and step back and truly appreciate, some of your incremental wins. Celebrate that with your team and kind of remember to learn from them and learn what you've done in the past. Always remember that you're adapting to something better. It's a journey. Enjoy it. And in platforms especially, the tech is complex, but the people are really the hard part. So make sure with your tenants you're developing really good feedback loops with every iteration that you make. Platform evolution, like natural evolution, is gradual, and it never stops. Thank you, everyone, for listening to our talk today, and we'll take some questions.
And if you have feedback, and feel free to leave feedback, good or bad, on that QR code if you'd like. Yeah, see one hand right here, I think.
I'm curious how the CMDB is populated. Where does that come from, and how do you end up using it?
Yep. So the question was, how is the CMDB populated, and where does that come from, and how do we end up using it? So the CMDB is like Capital One wide, right? It's not something that we run on the cluster. It's just your typical config management database solution. So we there are other processes internally for creating things in the CMDB, and then what we do is we validate against that as a source of truth to say you're giving us information that is accurate to the CMDB, right? So ultimately that's kind of managed out of band of what we're doing. And we just ensure that since a lot of our controls are based around that, we just make sure that we're complying with them, if that makes sense.
We're not wholesale importing the entire CMDB into our cluster. If that was kind of the point of the question. It's the onboarding point for our tenants. So they have to say, hey, I have this intent to move to your cluster, and here is my CMDB item, right?
Do you guys use the clusters for network segmentation primarily?
So, yes and no. The network segmentation, it kind of depends on several different factors that that it would take me a long time to spell them all out, but there's a mix of, like, because we provide node pools for each CMDB application, we can segment based on that. There are some, depending on our requirements in the application, they might have special subnets or special clusters. So it's kind of a mix of things. There isn't, it's complicated basically, depending on the application.
And to add to that, I mean, the requirements for what institutes a new cluster changes year to year, which is why it's so important to get to this clusters as cattle situation, because, you know, one day it might be that, hey, this is the definition of what needs to be a new cluster, but then in 6 months, oh, we got to move all these over here because that risk profile isn't the right one, right? So.
Yeah, and we have, like, ultimately, we have multiple controls, so depending on the criticality and the risk of the app and all that stuff, like, it could be a new account, it could be a new cluster, it could be a new VPC, it could be a new subnet, it could just be a node pool, right? So it depends on a lot of factors, but we have multiple levers to turn there. Oh,
I think
are we good to take this one? Last one?
last question.
All right.
You got this one?
Sure.
I'll start and then you can.
Yeah.
I won't say that we have the most robust testing suite, but it's pretty good.
Yeah.
You know, we reserve several clusters just for testing our operators to make sure that the changes that we're making make a lot of sense. We might put together a test suite that, you know, we're going to test creating all of these resources and then validating them and then spinning it down and up again. So you're really looking at that kind of a testing scenario to make sure that you're not going to introduce anything wild.
Yeah, like, I think it's somewhere over 100 tests run every time we make a deployment to the operators to make sure that we haven't broken backwards compatibility or, you know, the worst thing is if you roll out something to one of the larger clusters and all of a sudden it's reconciling everything wrong. Knock on wood, our tests have caught anything major from happening. But yeah, it does take a little bit, like, we've shifted our approach to testing a couple of times, and the person who's the real expert there is not here with us today, but yeah, like, testing operators can be kind of tricky. Like, it takes a little bit to set up and really get those tests going. But once they're there, like, yeah, they've been working great for us.
Thank you.
But yep,
Stick around and ask us questions afterwards. We'd love to talk.
Yeah, appreciate it.